Hello class, let's take a look at this problem right here. This is a hypothesis test, but specifically it is a hypothesis test with independent treatment. We have two samples. The summary statistics are reported here, okay, and more importantly, they provide us with sample means and sample standard deviations and sample sizes. Complete parts A through B. Alpha is 0.05. So the first question is to state the null and the alternative. And in order to do this, I need to read the question. Okay, the study was done on body temperatures of men and women. The results are shown in the table. The two samples are independent. Okay, complete parts A use alpha to test the claim that men have a higher body temperature than women. Okay, so that means mu1 is greater than mu2. Okay, which means that A is going to be the hypothesis test. That is, this is a one-tail test. Okay, now they want us to find the test statistic. Okay, so let's use StatCrunch to do this. So go to Stat, T-Stat, to sample with summary. The sample mean for the first result for men is 97.69. Standard deviation is 0.98, excuse me. Sample size is 11. For women, it is 97.28. The standard deviation is 0.72, and the sample size is 59. Now you will note that the sample sizes are actually pretty seriously unbalanced here, but we're not going to address that. Okay. Now, it says right here, there's a key piece of information right here that they tell us. Okay, it says here, do not assume that the population standard deviations are equal. So what that means on my settings is that I will not be pooling the variances. When I pool the variances, that means that the standard deviations are essentially the same, but that's not the case here. So change the alternative statement to greater than, and I am ready to make my calculation. Let me move this up just a little bit, right there, and hit compute. And here are my results. So the test statistic to 2 decimal places is 1.32. The p-value is reported right here, 0.152. or 0.15 or 0.105, excuse me, 0.105. And what's the conclusion? Well, the p-value is bigger than the alpha, therefore we will fail to reject the null. There is not enough evidence to support the claim. Now they want me to construct a confidence interval. Now we have to be careful here, okay? Let me tell you why. We're doing a hypothesis test with alpha 0.05. More importantly, this is a one-tail test. To find the equivalent confidence interval, we have to put alpha 0.05 in each tail. Why? Because a confidence interval, by definition, is a two-tail scenario. So when I actually find the confidence interval, it's going to be at a confidence level of 0.9, not 0.95. And again, why is that? Okay, because the hypothesis was a one-tail test, and I want to find the equivalent confidence interval, which by definition has to be a two-tail test, 0.05 per tail. So let's go back to StatCrunch and then go back to Stat, T-Stat, to sample with summary. We'll have to re-enter the data again. So 97.69, 0.98, 11, 97.28, 0.72, 59. And now we're going to use a confidence of 0.9. And again, why do I have to do that? Because I want to find the equivalent confidence interval for the hypothesis test. Because the hypothesis test was a one-tailed test, and all confidence intervals are by definition two-tailed tests, I have to take alpha 0.05 per tail for a total of 0.1. 1 minus 0.1 is 0.9. That is the confidence. So we're ready to hit compute. And here are my results. So for the lower limit, I've got negative 0.008. Negative 0.008. And for the upper limit, I have 828. 0.828. Okay, now you'll notice, okay, that I failed to reject the null, okay, which means that in essence my data was not sufficient. I have to assume that the null hypothesis is true if I fail to reject the null. Notice that this confidence interval, okay, the difference of these means includes a difference of 0. So this result is aligned with the result above. Okay, now I didn't like this, and I know what I did wrong, okay? Let me go back and repeat this. I made a mistake here. Let's go back and do it again. Stat, T-stat, toSample with summary. I forgot to turn off pooled variances. Did you notice that? 97.69, 0.98. So unfortunately, there are lots of settings here, and you have to remember, okay, to make all of the appropriate selections. So let's turn off pooled variances, and again, change this to 0.9, and then move this up just a tad, hit compute, and now you can see the results are substantially different. Negative 142 to 962. So let's try this. 142. And then the upper limit is, whoops, 962, I believe. Yes, that's correct. So let's try this one. And indeed, we have gotten it. So does the confidence interval support the conclusion of the test? Well, yes, it does, because the confidence interval contains 0. Thank you.